Alright, so to introduce the next idea we're going to do this thing called a simulation of a sampling distribution. And I'm going to be doing this in StatCrunch. You're always more than welcome just to watch me do it the first time, but then doing it on your own is still strongly suggested so that you can see what happens yourself as you're going through it. This is going to kind of do a lot of my directions for me. So I'm going to go to Applets Sampling Distribution. So I just brought up a blank StatCrunch window. I'm going to go to Applets Sampling Distributions. Then as it says, I'm going to choose binary, set p equal to 0.4, and then hit compute. So this is what we're going to be working with. So it says first I'm going to change my sample size that you see over here. So I'm going to change that to 10. So let's first sort of give this setup of what I'm working with here. So imagine in front of you that you have a very, very large box of beads. And in this box, 40% of them are black, and the other 60% are yellow. Right? So we have black beads and we have yellow beads. So this is giving me an idea of what my population looks like. So the ones would represent my black beads, and there's going to be 40% of them. And 60% of them are the yellow beads. I'm going to just be focusing on those that are black, though. So that's me, my focus, my variable that I'm interested in is just going to be the black part. And so from this huge box of beads, I'm going to pull out 10 beads and record their color. So anytime I see it go to 0, that means it was a yellow bead. Anytime I go to 1, that just means it was a black bead. And so we're just going to do this one time. And you'll see the sample go. Just put in black beads, yellow beads. So I had 9 yellow beads in that sample, 1 black bead. So that means only 10% or 0.1 of them in this sample happened to be black. And so it put a little bar down here as well. So I had 10%, that's what between this 0 and the 0.2 is going to be at 0.1. So that's where that sample proportion was. So I took a sample of 10 beads, recorded the percent that were black, and put that number down here. Alright, now I'm going to reset it like it says. I'm going to do this 5 times. So what you're going to see is it's going to collect a sample of 10 beads, calculate the proportion of black beads, put that number there, take a sample of 10 beads, calculate the proportion of black beads, put the number down there, and it's going to do it 5 times. Alright, so this time is 30%. 10%, 50%, 40%, 50%. So in my 5 samples that they took, one time they got 10% black beads, one time they got 30% black beads, once they got 40% black beads, and twice they got 50% black beads. And what you'll also see over here is it says how many samples that I took. It took the mean of those 5 numbers, also found the median of those 5 numbers, and calculated the standard deviation. Now mean and standard deviation we've seen before. Median, right, is just the middle number. So if I look at that 40%, 2 of the other values are below it, 2 of the other values are above it, so it's the middle value that we see there. So it says we're going to go ahead and record those numbers. So I'll record them here as well. So we got a mean of 0.36, a median of 0.4, and a standard deviation 0.1673. And I'll just show you where I recorded those. And then up here when we got that proportion of ones, that's a p hat. Remember that symbol, that sample proportion value. So here's what we've got so far. Now as it says, I'm going to hit reset. I'm going to click 1,000 times. So what's going to happen is it's going to do the idea of what we just did with 5 samples, but it's going to do it 1,000 times. It's not going to actually show us each time what it's doing, but imagine that it's taking a sample of 10 beads, calculating the proportion of ones, putting that number down here. It's doing 1,000 times. It's just doing it all very quickly. Okay. So here's what our graph looks like. So we can see we got 0 black beads or 0%. This is time or 2. I can't tell you exactly how high that is. We got 10%, a little bit less than 50 times. We got 20%, roughly about 125 times. So I can see how often I got each of these proportions. So we got 0 black beads, 10% black beads, 20%, 30%, 40%, 50%, 60%, 70%, and 80%. But in none of my samples did I get 90% or 100% black beads. So it kind of shows you what happened. Now we're going to record down our mean, our median, and our standard deviation, just like we did above. Alright, so my mean is 0.3928. My median is 0.4. And let's just pause for a moment. Do those two numbers make sense? Well, what percent of all of the beads are black? Well, I said that, right? I said 40% of all the beads are black. So I would hope to get 40%. So the fact that mean and median are really close to that 40% is a very, very good thing for me here. And then the standard deviation, remember, gives us our idea of the distance we fall away from the mean is about 15%. But we are also only sampling 10 beads, right? So if you're off by 1 bead, you're already 10% off here. Alright, now we're going to do the same thing, except I'm going to change my sample size. It says in the notes we're going to go ahead and jump to doing it 1,000 times, so I'm just going to do it one time again just for you to see it. So we take a sample, and this sample we had 12 yellow beads and 8 black beads. So take 8 divided by 20 to get that 40% and put that number on there. So I'm just going to do that 1,000 times. That it's going to take a sample of 20, calculate that sample proportion, and put it on our plot. So here's what we get. So the first thing you'll see is, right, some different numbers became an option, because now that we're sampling 20 beads, I got 10%, 15%, 20%, 25, 30, 35, 40, right? So now there's more options. That's why there's more bars that I'm working with. Looking at my mean and median, they're actually pretty darn close to what we had the last time. So let me record our numbers here. So our mean this time is 0.3948. Our median again was 0.4. And our standard deviation is 0.1147. Now that I have all those numbers, sort of compare them, right? So the means were pretty close. The medians were exactly the same. Standard deviation did change a little bit. Let's just remind ourselves of what I changed. Up here, we were taking a sample of 10 beads. Here, we were taking a sample of 20 beads. So if you had to predict what's going to happen if I change my sample to 50 beads. Alright, so that's what we're going to do. Do you think the mean will change? If so, how? Do you think the median will change in comparison to our other two? If so, how? Do you think the standard deviation is going to change? And if so, how? How do you think it's going to have an effect? A moment for you to think if you have any predictions of what's going to happen. Well, let's see what we do get. Okay, so I'm just going to reset it, change this to 50. So again, what's going to do now is it's going to take a sample of 50 beads, record the color, calculate the percentage of black, put it on here, and then do that again and again and again. And do 1,000 times automatically. So here's what our graph looks like. And we have our mean, we have our median, we have our standard deviation. So I'm going to write those down. So let's look at those. So here's our mean, our median, standard deviation. Did your prediction hold? So what we should have hopefully seen happen, the mean didn't really change much. The median stayed exactly the same. And the standard deviation got smaller. So I'm going to say my mean and median didn't change. And our standard deviation got smaller. So remember, standard deviation is measuring how different our values are from each other. So why would our standard deviation get smaller? Well, what that means is that our numbers, our samples, are more similar to each other, right? So each one of these heights, these bars, right, are all these different samples that we took. And so imagine that we had 1,000 different people that all took a sample of beads and recorded the percentage that were black. Our numbers are more similar to each other than when we only sampled 10 beads, right? Our values were more spread out. That's what that standard deviation changing means. Now we're going to take this idea and extend it here a little bit. So this is a reminder of some symbols here. So P represents the population proportion, and P hat represents our sample proportion. So as we just saw, that the sample proportions, our P hats, our statistics, can be different based upon who our sample is, or here which beads are in our sample. But we can actually predict how much we expect these to vary. This is sort of an idea from our standard deviation. So in our activity, here's the things that we should have noticed. So as we took a larger sample, so we looked at an N of 10, then we switched to an N of 20, and then we switched to an N of 50. Here's what we should have seen happen. The mean and median did not change much. The standard deviation got smaller as our sample got bigger. And we saw this on our graph too, that it was less spread out. The last thing we should have noticed is if you look at this plot, especially once I change my sample back to that 50 that we did, right? Our graph kind of has this symmetric, bell-shaped, normal picture that we've seen before, right? Our graph is beginning to look like that curve that we were drawing early on. So the graph looks normal. And of course, by normal, I mean my picture over here. I began to have that shape to it. So what we hopefully saw in this activity was we can get different samples. But when I know my sample size, I can predict kind of how different these values should be depending upon who's in your sample. I can have an idea of how spread out my values could be. I know right now if I change my sample, let's change it to 200, it's going to be even less spread out than it was before. So you look at how tight all those values got to be. And I know that I can use that to help me predict what's going to happen. So we're going to use these ideas when we look at our next video. We know the mean and median didn't really change. We do know though that sample size, this n, did affect our standard deviation. And we know some things about normal distributions that we can use. And that we'll see extend into our next video.